Welcome to this video. In this video, we will continue with particle size distribution. We will start and we will continue the index properties. So, particle size distribution. What is the aim of making particle size distribution is to find out percentage finer than a particular size d. And what is this size d? That is dia of soil solid. The scale which we have is 2 micron, 75 micron, 4.75 mm, 80 mm, 300 mm. This is the diameters. These are the diameters. So the fraction of soil which lie on this range, that is which are greater than 300 mm, are called as boulders, means the larger solid particles, boulders. In this range 300 mm to 80 mm, it is cobble. This range pertains to gravel. In this range sand, this is silt, and this is clay. That is, clay are such soil which are lesser than 2 micron size, and I have said 1 micron equal to 10 to the power minus 3 mm. And also in this scale, from the demarcation is made, there is board classification, general classification regarding type of soil. These, if the soil is such that soil solids are greater than 75 micron size, then they are called as grained coarse grained soil. If they are finer than 75 micron, then they are classified as fine grained soil. Okay. Now, a soil a soil may consist of all these fraction in it. Means a soil may have all type of particle in it. That is, it may have gravel, it may have sand, it may have silt or clay, or a summation or a aggregate of all those. Okay, the composition of soil may contain particles of all these. range. So gravel and sand are called coarse grained, silt and clay as fine grained. As I have said that the aim of making this particle size distribution, okay, is to find percentage finer. Then what is this percentage finer? Let us try to understand by making a experiment or by taking an example. So we have to find percentage finer than a particular size. So let us take the sieves of standard size. First of all, let us consider a soil sample, a soil sample of 100 grams, and this soil contain all the particle, means the particles are distributed uniformly, not uniformly actually, in different composition, in different proportions, but they have all those particles are distributed in soil sample which we are considering. So it contains gravel, it contain also it some fraction of sand, it also contains silt and clay. Okay, so let us consider standard sieves. So let this be 80 sieve, let this be 20 sieve, let this be 4.75 sieve, let this be 75 micron sieve, and let this be 2 micron sieve. Okay, sieves. What do you mean by sieve? Jali. Sieve means jali. Now, what we will do, the 100 gram of soil which we have taken, we will try to pass it through this sieve. This is the 100 gram. So if on falling over 80 sieve, let some fraction retained over this, okay, and some passes. So let 10 grams retained, so 90 gram will pass. Now let over this some fraction retained over 20 micron, let this be 20 grams. So the percentage passing will be how much? 70 grams. Now over this, or 4.75 let some fraction retained and let it be 30%. So passing 40%, or no, I'm representing gram, you should write in gram. So let over 75 micron 35 gram retained and passed is how much? 5 grams. So now let over 2 micron 3 gram retained and passed 2 grams. So this is the experiment which you have conducted. Now if you were asked that percentage of soil finer than 80 then what will be your answer? It will be obviously 90%, because 90% of soil has been passed. Yes or not? Similarly, percentage finer than any diameter, any size of the soil solid, what it will be? It will be that what portion of soil is finer than that particular size of soil solid. Hence this is the concept of percentage finer, and this is the only thing which we have to find. So make a look here. In this soil sample which we have considered, the coarse grained soil, what is the fraction of coarse grained soil here? It is almost total portion of coarse grained soil. What it will be? Look, as here at 75 micron I have said the soil fraction of which size is less than 75 micron soil solids, they are considered as fine grained soil. So what amount of soil is passing? It's 5 grams only, and above it total cumulative percent, what is the total amount of soil get retained over 75 micron? 10% plus 20, 10 gram plus 20 gram plus 30 gram plus 35 gram. If you will add, you will get 95 grams. Yes or not? Hence fine soil, fine soil, this is sand plus gravel. So fine soil portion is 5 gram only in this sample which we have considered. So what is this fine portion? This is silt plus clay. And make a note here that percentage of silt and clay, that is size of soil solid lesser than D equal to 75 micron are called as percentage of fineness in soil. Okay, so what is the percentage? So in this sample what is the percentage of fineness in this sample? It is 0.5%. It is also not 1%, it is 0.5%. So in this sample it will be what? It will be 5 gram over 100 gram into 100. Yes or not? So it goes 5%. Okay, so percentage fineness in this sample which we have conducted a sieve analysis on which is 5%. So why this percentage fineness is? As I have said, the fine grained soil, fine soils are more compressible, as we have seen in the previous lecture videos, that the volume of voids are more in case of fine soil. So those soil which are having more percentage fineness will be more compressible than other kind of soil which having low percentage of fineness in it. Okay, means compressibility will be low, volume of voids will be low if percentage fineness is low. So this is the idea for which we have to understand the what is percentage fineness. So let's proceed towards the actual basic analysis method. So how do we find the particle size distribution? So methods, there are two methods there are two methods which are different. Means for first method is for coarse grained soil, it is mechanical method, mechanical analysis. And It is for which soil? Coarse grained soil, coarser soil, coarser soil. That is, I am writing repeatedly because you will be remembered. Coarser soil, sand plus gravel. Okay. This method is also called a sieve analysis. You have to use sieves in finding out percentage finer in case of coarse grained soil. Hence, it is a mechanical method, sieve analysis. And second method is for fine grain analysis. Fine soils, fine soil, that is clay plus silt, and we perform fine grained analysis. This is also called as sedimentation analysis, which we are going to study in detail, and sedimentation analysis is the most toughest part of this soil mechanics. Okay, so be attentive. Sedimentation analysis. Let's make a chart actually to be clear. So you should remember this chart which I am going to make now. Particle size distribution. It has two groups. It has two groups. The first is coarse and coarser analysis. Or mechanical analysis. For sand and gravel. For sand and gravel. Or sieve analysis. Now here we have fine grain analysis for silt plus clay, that is D less than 75 micron, or this is also called or sedimentation analysis. Sedimentation analysis. Now this sedimentation analysis is grouped under two categories. There are basically two methods by which we perform sedimentation analysis. First is the pipette method. Pipette method. Second is hydrometer method. Hydrometer method. Okay, we will study this in very detail. These are important one. So hydrometer method, because there are a lot of objective question hiding in these topics. Hence, this chapter, the first chapter of soil mechanics, which is a lengthy theoretical one. So any soil engineer must deeply understand the first theoretical portion, initials of the soil mechanics, because instead of understanding this, you will prefer that I will study permeability directly or consolidation directly, or you will try to study the shear strength. It will be totally zero effort. Okay, so you must put effort in understanding these topics, then that will be easier to understand. Hence, so let's complete the flowchart. So this is sieve analysis. Now There are two type of sieving. There are two sieving: coarser, coarser sieving, okay, and fine sieving, fine sieving. Now this coarser sieving is for gravels, gravels D greater than equal to 4.75 mm. Make a note here. I have written that greater than equal to. This is important. Why greater than equal to? It will be clear in coming sections. Now fine sieving. This is allowed for sand. This is conducted for sand. That is less than 4.75 mm, greater than equal to 75 micron. Greater than equal to again. And this fine sieving is of two categories again further, which is wet sieving, wet sieving and dry sieving. So this is the approach in which we will study. First we will study the sieve analysis, the coarse grained analysis, then we will continue fine sieving, then after we will go for fine grained analysis. So let's start with coarse sieving. And what are the objective portions which were asked in coarse sieving? Coarse sieving. As I have said, it is a mechanical method and it is done for gravel soil. Gravels are the sample. Okay. Size ranging from 80 mm to 4.75 mm, equal to 4.75 mm, because the particle size which are just equal to 4.75 mm are considered as gravel only. They are not sand. Then what is sand? Sand is the particle size which are passing, okay, which are passing through 4.75 mm and retained over 75 micron. They are called as sand. And also under sand there are different category, means above 4.75 mm to up to 2 mm they are called coarser sand, and below 2 mm to 75 micron they are fine sand. So we will look into that in when we will study the soil classification. So now just for idea I have said that. So the important thing we anyone should note while studying this is we are using sieve, and the sieves used in analysis are either designated. You should have idea of sieves, that which sieve you are going to use. There are two different classes of designation. Either designated by its square opening square opening or by its sieve number. What is this? It will be clear in coming sections. Or by its sieve number. There is these are the basics which anyone should understand. So make a note here that according to IS 460 1962, this is the code for sieve, and this code recommended that 1962 a recommendation made that the sieves used must be designated by its square opening. Okay, this is the recommendation of code. But there are two schools of designations. One is the we use to designate by its square opening. Square opening in sense like this is a sieve, and you will check that you will check the individual opening and what is its size. As it is square, let it is 2 mm, so it will also 2 mm. So what is this sieve? This sieve will be designated as sieve of 2 2 mm sieve. Its designations will be 2 mm sieve. So having this understood, let us try to make a idea about what is sieve number then. Sieve number. So consider two examples. Let us take two examples of, let us take actually two numbers. Let we have taken 6 and let we have taken 10. So what is this 6 is? Let for sieve number 6. Sieve number 6. What is this? Let this be the sieve. Okay. Now you consider 1 inch length in two different directions, because you have to make a square actually. So let this be the 1 inch square of 1 inch. So in this square, if there are in this length 1 inch length, and this is also 1 inch, this length is also 1 inch. What is 1 inch? It is 2.54 centimeters. Remember this. Students get pretty confused while making the unit conversion from inch to centimeter. So just remember it is 2.54 centimeters. So in this 2.5 centimeter in this direction and both direction, if there are six number of equal squares, equal square in 1 inch square of area, yes or not? In 1 inch square area of that sieve, if there are such divisions that there are 6 equal square openings, then that sieve will be sieve number 6. This number of that sieve will be sieve number 6. Hence for sieve number 10, what it will be? There must be 10 equal square opening in 1 inch length in both directions. What does it mean? I have said all this because we will draw a conclusion which is being asked in objectives. So the conclusion is, what is the conclusion? The conclusion is that, yes, higher the sieve number, okay, if let for sieve number 10 and sieve number 6, if you will compare the square opening, size of square opening, which will be higher? In which case? Obviously it will be higher in case of lower sieve number, because in the same length there are only 6 square openings of equal size, and for 10 there are 10 square opening of equal size in the same length. Okay, what does it mean? It means that higher the that higher the sieve number, lower will be the size of square opening. Okay, So this is the conclusion we have drawn ultimately. So now let us proceed. So we are in we are looking into mechanical or coarse grain analysis. What we do is we place some standard sieves. First of all, note the standard sieve. What are the standard sieves? Standard sieves used. Standard sieves are, in this case, are 80 mm sieve, 40 mm sieve, 20 mm sieve, 10 mm sieve, 4.75 mm sieve. These are the standard sieve, and these standard sieves are placed from as a top to bottom column. Okay, there is a stack. There is a stack. Look like this, something like this. It is a stack. It is a stack, and in at this stack there are arrangements in which you will place the sieves. So sieves are placed from top to bottom. The orientation is from top to bottom, and the order is decreasing decreasing sizes. Okay, in this stack, this fashion, the sieves are placed. So let this be 80 mm sieve, this be 40 mm, and so on up to 4.75 mm. So this is the order of stack in which sieves are arranged. Now after arranging the stack, you will put the soil sample over here, for which you have to make the sieve analysis. So these sieves are, the sieving means the shaking of sieve. It's okay. You are not in a condition that you will just put the soil over the sieve and allow it to pass through the respective sieves placed in the downsides without any outer force. It is not so. We have to shake it. Okay, we have to shake it, and this shaking, so it is recommended that shaking of sieves is done at least for at least for 10 minutes. Okay, 10 minutes. You have to shake this sieves at least for 10 minutes in order to get correct result. 10 minutes. And it can be done by two methods. You can manually shake the sieves, or it can be done by done either, means shaking process, either manually or using a mechanical mechanical device. What is this mechanical device? There is a technical term called sieve shaker. Okay, this is sieve shaker. There is some input of energy, and means the energy which you are applying, it's not required. It will be the automatic energy, automated one. So sieve shaker sieve shaker, we can use both. It is the code recommended that sieving is at least done for 10 minutes, and this can be done by two ways, either by manually or by sieve shaker. This is the recommendation of code. So you can follow any one of the experiment, any one of the method, any one of the ways, and find out what is the aim of finding why you are conducting the sieve analysis. The ultimate aim was to find the percentage finer than a respective corresponding diameter of soil. And why we are finding the percentage finer, we will be discussing in the conclusion, while we will draw the conclusion for the entire sieving process, entire particle size distribution process. Then we will be looking into the aim of that objective. Aim that why it is required. For that aim we will draw conclusion that why we need to find percentage finder. For now the aim you should keep in mind that we need to find percentage finder of soil. So now let us proceed. As we have completed the coarser sieving, now for fine sieving, fine grained sieving, fine sieving, fine sieving. Look, I am writing sieving, okay, fine sieving or sand sieving because fine sieving is conducted for sand, sand sieving, okay. And as I have said that this is of two types. What are they? Wet sieving, wet sieving and dry sieving, dry sieving. So first of all note the standard sieves which are being used. So what will be the particle size range distribution in case of sand sieving? It will lying between less than 4.75 mm to greater than equal to 75 micron or not. Okay, this will be the range of particle size for which sieving is to be done in case of sand. So standard sieve, make you will I will point out a thing here. Standard sieves used, as in case of gravels we have you must notice that standard sieves used are were starting from 80 mm and ending with 4.75 mm. So that is the range of gravel, hence I have said greater than equal to. So that is the point of making a note at greater than equal to, hence the standard sieves used here will be starting from 2 mm, not 4.75 mm. This is the catch. So 2 mm, then 1 mm, then 600 micron, 425 micron, 300 micron, 212 micron, 150 micron and 75 micron. Notice this is the 75 micron sieve which we have used in sand itself. So for fine soil the sieve if sieves were used then there are no such sieve finer than 75 micron, I think. Not, I don't think it is the, there are no sieve really exist finer than 75 micron. Can you guess what is 75 micron? It is multiplied by 10 to the power minus 3. Okay, that small sized sieve. So these are the standard sieve, and the procedure of sieving is exactly same. That is, you have to sieve at least for 10 minutes, and it can be done in two ways, either by mechanically or manually. So that is the procedure, and the aim is to find percentage finder only in sand group. So now we have to understand that why there are two classifications, that is wet sieving and dry sieving. What are those? What are that? Now wet sieving. Why wet sieving of sand is done? Wet sieving. Wet sieving of wet sieving of sand. Why it is done? Actually, we will look into this. Wet sieving is done for sand if the sand contains some fineness. As I have told that the soil solid which are lesser than 75 micron are called as fineness. So if there is fineness in sand, that is there are some fraction of clay and silt also in that sand, then what we need to do is first of all we need to wash the sand under flowing water or running water such that the sand is gets segregated from the silt and clay portion, and the silt and clay portion washed away so that we get the pure sand, okay, not the impure one. And then after we will make the sieving. So this is the basic objective. So what is this? Let this be the, but there is a problem here, and the problem is very interesting one. So what is that problem? Let this be the sand grain. Sand grain. Okay. Now as I have said, if the sand contains this silt and clay fraction, then we need to conduct wet sieving. First we need to water wash. So let this be the silt and clay portions. Okay, that is silt plus clay. So now look into this. There is a bondage between silt and clay and sand. Now what happens is, while water washing, this the bondage do not break completely, and some portion remain stick with sand after water washing also. So to make this water washing process effective, what we need to do is break the bondage, means the love which is being created between silt and clay and sand. We have to break that. We have to make them opponent. So let this be the sand grain. Sand grain. Sand grain. So we have to segregate it. Okay, separated. We have to make them separated. This is silt and clay. So how do we do this? How do we achieve this? There is a hero called dispersing agent. There is a hero called dispersing agent. We mix dispersing agent to the water which is used for washing, and the role of that dispersing agent is to make the segregation, and once they are segregated, then they are washed away under the flowing water. So that is the objective. So what is that dispersing agent which we will using here is, the dispersing agent is used, dispersing agent is used to remove, not to remove, to segregate. Okay, to make them individual. Dispersing agent is used to segregate the sand grain from clay plus silt, means from the fineness. We have to make segregate. I have shown above. Dispersing agent is used. Okay, such that they, what are they, fineness, get effectively removed, because we need effective removal of them. Okay, else the sieving process will not occur correctly. It will be erroneous. You will get erroneous result. Why? Because the clay and silt are, as in nature they are sticky. Okay, as in nature they are sticky, hence they stick to the surface of the sand grain. Also they make attachment with another next sand grain, adjacent grains. So two grain will mix with each other, and they will not pass through the sieve. So that is the point why we need to remove the fineness. Okay, as they are cohesive, so they build up a cohesive type of sand. So we have to remove that cohesion. For that we are using dispersing agent to segregate them for effective removal. So what is this dispersing agent? So the dispersing agent dispersing agent used is a famous salt, and its name is sodium sodium hexametaphosphate. Make a note that the dispersing agent are generally sodium salt. Okay, dispersing agent we will encounter with this in while studying the environmental engineering. In that also we need to use dispersing agent in making effective sedimentation, effective coagulation. There at all those process we use dispersing agent. Okay, so dispersing agents are generally used to be sodium salts. So here the dispersing agent which we are using is sodium hexametaphosphate. It is approved by code. Okay, code which is for sieving. And what is means which code? It is IS 460 1962. Remember this, it will be asked in objective in IES exams. So now as we seen the name of dispersing agent, but how to apply this dispersing agent? How do we use this agent in mixed with water? How do we mix with water? Code says that the code says that 2 grams 2 grams of sodium hexametaphosphate is mixed in 1 liter of water. Okay, by mixing 2 gram of sodium hexametaphosphate, it is a solid. Okay, it is a salt, so solid. So by mixing 2 gram of sodium hexametaphosphate in 1 liter of water, we are going to make a suspension. Okay, a solution. We will make a solution. Then 25 milliliter of this solution, 25 ml of this solution is added to the water which is to be used for wet washing the organics and silt plus clay from sand for conducting error free grain size analysis. So here we completed the analysis for coarse grained soil. Okay, in I will end up here, and in next session we will discuss the another part, that is fine grain analysis. In that we will discuss the sedimentation method, and then after we will study the different types of sedimentation method individually. Okay, well, thank you.